So if you can see that the how I have done is this way. Basically, if I have to find out, you know, like I have taken this way. I'll show you. So these all things you guys have done in a similar way. And this one, so what I have done, I have to find the top 10 state country with the highest number of earthquake. So since we have a lot of, you can see that if we see the country state, there are few countries that are not available, right? So that's why I have applied a lambda function, okay, just to filter the type of earthquake, okay. It will only get applied on earthquake, okay. And here I have country, state, and count based on that, like group by. That way also you can do that. And if you have a filter data, then values count is also okay. But again, you cannot put the column name on the top of it. You need to reset index in that case also, in values count also. Got the point?
Yeah. How do we omit the value if country state is null?
Uh,
How can we omit the value, the first row,
uh-huh.
if the country state value is null?
How can you omit means you want to do? How do you understood? That's what you asked.
No, here in the lambda function where you filter based on the earthquake,
Uh,
can we also based on the country state is not equal to null?
country state is not equal to null.
Yeah, because you're trying to sort based on the country state and try to get the maximum count.
Uh-huh.
But if the country state is null, we don't know for which country state the record belongs to.
No, this is automatically going to give us an idea that the total count we are doing is not giving us enough. There are these are blank, so we are just counting. So based on that, these are the null values that is available there. So that's why it is printing over there. So later on, that's why what I have done here is I have taken based on the ID. So this is the ID number, and then later on I have printed all the country state of all the highest and weakest number of earthquake here, if you can see that. Later on, what I have done, once I've taken the data, this is my data frame, right? So now what I have done here is I have, you know, put the data into a sort values, and after doing sort values, I'm printing only their country state. Can you see that?
Mhm.
Yeah. Just to print only because the question asking us to print only the country state. So yeah, so you can continue.
Okay, sure. Sharing back the screen. Is my screen visible?
Yes.
Okay. So after use extract country, find the 10 states or countries which are where are the strongest and the weak earthquakes occurred. So this I have just applied. Where is it? I've just applied value counts directly on the country, and I have found top 10. After that, to get group by country and find the magnitude and top strongest earthquakes by country or weakest, I've just applied the country magnitude, and whatever the group is there, I've used the above logic itself to sort the values and get the strongest and the weakest earthquakes. After that, install US package for using this because they have the issues with the US states because it is not identified properly. So most of the data set you see here, Alaska is actually a state in US, it's not a country. So there are some other ones which needs to be fixed in the data. So as usual, I just created a list for all the ones that are in the US and wrote this function to check if there is there or not. and I have applied this on US state. So what this applied does is it gives you a Boolean true or false kind of a thing. So for every value in the country column, if it is a US, it returns true. If it is not in the US, it returns false. So based on this true or false series, I have set the reindex, and wherever it is nil, like you are not sure that, or where the country is missing by as Deepesh mentioned. So I've filled it default as false, saying that if you don't know what the part of that country is or the state is, you just assume that it is out of US because you will not be able to find it. So just did it that way, and by using lock, wherever it is true, I'm sending it as USA, wherever I have found it. And also the state, I have just applied the series with the count, and I have reiterated with the data frame. So I have got the country, I've got the state. You can see here Mexico, it's not in the US, it's blank again. So this way I was able to try it out. I think there are many other ways of doing it. I was Googling on a couple of ways of doing the same, like, how to apply this and do it. Okay. And the next part majorly, yeah, so here what they've asked is the same, the reindex this Boolean. So now we have to redo the country count because initially the values were different. So I just applied the same thing again, reanalyzed it by using the country maximum and sort the values, and printed the country with the maximum strongest earthquakes and with the the weakest ones. And the next part is analyzing the distribution of earthquake magnitudes in the filtered distribution. So here majorly, I think most of the answers were here itself directly. So they just asked us to draw the histogram based on the magnitude on a logarithmic scale to see the relationship. So where did I plot it? Here it is. So this is what. So I've just taken the MAC, based on this thing. So basically, I have filtered it. This is the DF filtered, where they have asked to filter whatever the magnitude which is more than 4. So this contains my filtered data, and on that filtered data, I applied the histogram with MAG on the logarithmic scale. I've just set the distribution name kind of a thing. So this is the distribution saying that as the magnitude increases, the count of on the logarithmic scale decreases. So it's exponential to the magnitude of the count is exponential to the magnitude on the logarithmic scale. Then same with the scatter plot. So scatter plot, again, I have earthquake have distributed based on the longitudes. So as you can see, the density of the earthquakes are more towards the positive longitudes rather than the negative longitudes. And that's the scale. And same thing they've asked us to do with the depth as well. So the depth, basically the trigger point of the earthquake. So on the higher positives, you have the higher depth earthquakes, and you can see others. And generally, both of them collide with almost the same, because it means that on the same, the longitude, wherever the earthquakes are happening, the same, the depth is also portrayed. It's similar. So yeah, that's it on the, yeah, that's it on the assignment part. I've just plotted it directly. I didn't use much of anything. I just used matplotlib to set the color bar and stuff like that. Any doubts or
Yeah.
anything?
Just a second. I don't have any doubts.
Any alternative ways of doing it, Dipesh?
You mean the plots?
Mhm.
Yeah, I mean, you can also use Seaborn to customize it and plot it. there is something called as one more package as well. When I was trying it out, not from Matplotlib. The first day, Deepesh has showed, right, couple of other packages. You can use those packages to customize it, because from what I've seen, this is more of a basic 90s level of picturization that you are getting, right, on the scale and stuff. But if you use the updated packages, you would be giving more texture to the way the plots come and the magnitude variations. Because if you see, most of this are embedded over here. Like you will not be able to see the magnitude of 8 or 7.5 and pinpoint it, because it's all on the same. But with the updated packages with Seaborn, where you have something like splitter plots or kind of a way where it does not embed one on another, you will be able to plot it more.
Okay.
Thank you.
Thanks, Vashu.
Okay, that's great. Okay, so I believe all of you have done some part of it, right?
Some of us tried Deepesh.
Okay. Yeah. Moving further, let us discuss what we're supposed to gonna do today. So as mentioned in our plan, we are today going to discuss about AWS, and we will be going to talk about the different services available of AWS, EC2 and S3 and all, and then accordingly we will be moving further. So that is an idea. So okay, so yeah. Now, what we have discussed, we discussed Python to work around like on uh, to do analysis, and to it will help us to do PySpark and all also, and how to do analysis with on certain data using some packages. The next thing that we're going to discuss is we need to do PySpark, right? So for PySpark, we require some platform where we're going to discuss this. So we require to install Spark and something like that. So, uh, like as I mentioned, if you remember, like you can use Spark either on Cloudera kind of services on in-house, or you can Spark on cloud, services. So different, like platform as a services and infrastructure as a services provided over cloud. Okay. So the similar kind of services being provided by Azure and AWS both. So let's discuss on AWS, right? So how many of you have worked on AWS and how many have not? Please mention. So I will take thing accordingly. Okay. So we have like 50-50 kind of thing. So few people have worked, we have not. So let me just quickly walk you go through about our, services that is available on AWS. So as you know that Amazon Web Services is, like one of the you know, first before even AWS or something, let's understand what is cloud computing. So you all know that the when we leverage the idea of storage, computational resources, or anything that we were able to do using our like in premises servers that we wanted to do on internet basis, that is available on time based on anywhere, is called cloud computing. So in simple word, it means storing or accessing your data and programs over the internet rather than in your on hard drive is called cloud computing, right? And the cloud computing is actually we will able to do because of techniques called virtualization or containerization. So what is virtualization? Any idea? Anybody gonna speak up? Hello.
Basically, I guess in virtualization, the resources of the original server are
Mm.
used up, right? And then based on the top of that, we can create different instances of the servers or
Right.
the containers
Right.
we want.
So when we create a server, so how we can make a server that anybody can access, multiple people can access. So let's suppose we have a host system. Let's say this is my laptop, and I want you to access. Like we have installed Cloudera inside our on system, right? So what I have done on the top of my hardware, there is an operating system called Windows. In Windows, I have installed a software that will enable to do virtualization. That's called hypervisor. So hypervisor is a software like VMware or VirtualBox is a software that is nothing but it's a hypervisor. Hypervisor will allow you to install another guest OS, okay, guest OS. So another operating system we can install and then we can work around it. You can install another software inside that and you can do that. So virtualization is not so efficient in today environment because let's suppose if there is a problem in guest OS, okay, then again you cannot use any other software that is being installed inside it. So that's why there is another technique came into the picture that's called containerization, right? So containerization is what like instead of hosting guest OS multiple time and then of installing software, we do Docker. We install Docker. You know Docker if anybody have worked around it. So we can create container application. So once the container application once the Docker has been installed or the containerized, been installed, then we can install into form of small containers that have some certain amount of hardware, RAM, and other access, and that's how we will able to install, right? And that is how the cloud services are also, giving us services. So cloud have these three different model, just to tell you. One is called infrastructure as services, platform as a services and software as a services. So the one that is called infrastructure as services in which client has a full control on configuration of compute and storage and network resource and we can pay as you go. Like in AWS we have EC2. So in EC2 it will allow us to install another operating system and then we can proceed further, right? That is how we can work around this infrastructure as a services. And then we have a platform as a services. So platform as a services is something like we can create different platforms on the top of it. And no, we have already some platform services in form of provided like EMR, AWS Glue. These are nothing but it's a platform as a services. So where we can actually do just need to write a program and then that's how the processing happens. So a service provider offer access to a platform on cloud-based environment in which user can build and deliver applications and the user does not need to deploy and maintain any underlying infrastructure on the top of it, right? That is what in a platform as a services we can work around. And the next is software as a services, software as a services. So when we say software as a services, software as a service is the end applications. So let's say Gmail, Facebook, or you can say like there are multiple software as a services are available that have we don't have any control. We can use or interact with the application. Okay. So service provider delivers software and applications for all the internet user to subscribe the software. Yeah. This is just a kind of like the access that you have. So as I already mentioned, some certain definition. This is what. Yeah, so as there are multiple public cloud providers, public cloud provider means anybody can, like AWS, Microsoft Azure, Google, Alibaba, multiple clouds are there. So Amazon Web Services is one of them. Then Microsoft Azure, Amazon Web Services, IBM, DigitalOcean, Salesforce, Oracle, and many other more. So AWS Amazon Web Services is, is a very fast, scalable global cloud-based product that have multiple other services to compute, store. It's have database, analytics, networking, mobile, developer tools, management tools, IoT, security, and enterprise applications. So Amazon Web Services is on demand that is available in second within as pay-you-go pricing, and it has more than 190 plus services now, right? So it's keep increasing again and again, again and again, right? Now, what is the history and evolution of AWS? Just quickly, give you a brief understanding. In 2006, that's when it started. Now, available in more than 190 countries and all, multiple users of AWS. And the most important part is there are different availability zones and different servers that is deployed around across the world. Okay, so you can see that there are 24 launched regions, 3 announced regions, and multiple other global servers are there as an infrastructure of AWS. These are the different in India. We have in Hyderabad, Mumbai. I am aware of these 2 locations. So a region is a specific geographical location that is subdivided into zones. So these are the zones of this. Then different services, as I mentioned, for compute, store, networking, IAM access, identity security, deployment management, mobile services, container application, IoT, media services, multiple. So multiple services are there. This is how you can see that. Yeah. Uh, if you talk about the compute services, for compute, you have multiple services like Amazon EC2, Elastic Cloud Compute. We have Elastic Load Balancing, Amazon EC2 Container Services, Lambda, Auto Scaling. For networking, we have Amazon VPC, Amazon Route, S3, AWS Direct Connect. Storage, Amazon S3. Amazon S3 is for storage, data lake for us. Amazon Glacier is there, Amazon CloudFront, Amazon Elastic File System, Amazon IAM Access for security and all, Amazon CloudWatch, CloudTrail. Application we have directly Workspace and all. Yeah, so these are the services are there. Just allow me 1 minute.
So Deepesh, on this storage here, so we have this different services, right?
Yeah. So
S3. So what are these specifically meant for?
which one?
Storage. We have EBS, CloudFront, Glacier.
Yeah, so I will be discussing on storage first of all. So we have multiple storage services. These are the foundation services. So in foundation services, like as I mentioned, these are the storage application, multiple services are there. Then for database, we have Amazon RDS. For data warehouse, we have Amazon Redshift. For DynamoDB, like the unstructured, the one NoSQL database, we have Amazon DynamoDB, we have Elastic Cache for cache data and all. For analytics, we have Amazon Kinesis, EMR, AWS Data Pipeline, AWS Glue. For app services, we have Cloud Search, Amazon SES, multiple services are there. Okay. So and when you talk about, I'm just telling you a simple web application, how a simple web application can be done over AWS. So let's suppose a person who is having a domain that's called www.abc.com, and he wanted to create a complete web server. He wanted to create a complete website. So how he can use that? First, he will use to balance the load of all the traffic that he's getting. He can use load balancer. He can use for cache and all this Redis cache, and then he can use S3 bucket CloudFront to watch all the stuff, and then EC2 where he can install all this an RDS database and all. That is how he can create resources, and he can let them communicate the users. So there's a complete discussion required just to understand in detail, but I'm just telling you multiple services assimilate together and allow you to do this. Like if I talk about in R, the top services that is being used on Amazon, the one is called EC2. EC2 is Elastic Cloud Compute. Elastic Cloud Compute will allow you to create your own virtual machine. So let's suppose you might have seen in your organization, sometimes organization allow you to give access of third-party system, or the data, or you can say that a operating system within some certain restrictions or something like that. So that all this stuff has been installed inside EC2. Even though in our Spark, let's suppose you want to install a Spark. I will show you how to do that. Let's say you want to install a Spark and Jupyter Notebook where you can program your PySpark programming inside EC2. So you can create a operating system inside EC2 in a form of, let's say, Ubuntu Linux-based system we require. So in Linux-based system, then I will install all the services inside of Spark and all, and then we can actually access PySpark with the help of Jupyter Notebook. So we can install inside EC2 and we can access this, right? S3 is for storage, simple, storage services is there. Okay, so multiple of them, IEM access, load balancer, CloudWatch, CloudFront is there. These are the multiple, different services being used. So the one service that I'm supposed to gonna discuss little in detail is the AWS data pipeline, right? So here in AWS data pipeline, if you can see that, first you could have different data sources, right? Yeah. So this is your data sources. You can have multiple type of data sources, right? Then you can ingest the data. So here for ingestion, there is a services in AWS that's called Kinesis. So Kinesis can do, batch processing, streaming processing, any kind of data you can ingest from different other resources, right? Then you, after ingesting the data lake that you have, okay, this is for the batch processing. Batch processing means when you have a data that's coming after some point of interval, right? So for this is you dump the data into S3 storage, okay? Storage is nothing but it's a data lake for you, right? Now here, either you can use Databricks. So here you can do that. We will be doing the same thing. Either you can use this in our Databricks. So once you use the Databricks, okay, you can do ETL and other thing, okay, and then you can process batch views and all, and then you can, store the data inside a data warehouse. This is your data warehouse, and then, this is AWS QuickSight, that is for visualization. For the point. Yeah. And if you have a streaming data in AWS you want to use, so Kinesis have different services, Kinesis analysis, Kinesis Firehouse. Okay. So Kinesis analysis will allow you to stream the data, and Firehouse itself have capability to do data analysis or ETL. And then again you can store inside a data warehouse, and then the visualization will happen.
Is Kinesis analysis analogous to Kafka?
What? Correct. It is similar like a Kafka. So that is a, there are multiple pipeline can be created, multiple types of pipeline can be created. And yeah, I mean, this is one of them.
What did you say about this firehouse? Firehouse?
Hmm? See, Kinesis have multiple, availability, like Kinesis have, Kinesis have analysis, Kinesis have Firehouse. So Firehouse is the, having a capability, not just to, Kinesis analysis is ingesting the data, and then Firehouse is having the capability to analyze in a real time and, like do batch processing and do a complete detailed analytics on the top of it. So Amazon Kinesis, Firehouse, Kinesis have a data stream, and Kinesis have three services of Kinesis have data stream, Kinesis analysis, and then Kinesis Firehouse. So Firehouse is primarily focused on data delivery. That can do ETL jobs like transformations and other format conversions. So these things are capable by the Kinesis Firehouse. Okay.
What is the third component you mentioned? Kinesis data warehouse,
Kinesis data stream,
data stream.
Kinesis analysis, Kinesis Firehouse.
This data stream is for storing data?
Data stream for streaming the data, like
Streaming.
Spark streaming is doing for us, or Kafka is doing for us. Similarly, Kinesis analysis do the same to convert or read the batch, so streaming data into form of batch.
No, analysis is similar to Kafka, which is for streaming data. Firehouse is for data delivery and
Analysis,
ETL.
see, Kinesis analysis also do analysis on kind of a batch processing data. Okay, it's a Kinesis analysis is having like a capability to like to analyze what we have read through the Kinesis D stream. Okay, Firehouse is more capable than Kinesis analysis. Okay, so Firehouse is able to do kind of a detailed real-time analysis. So that's what the capability of, Kinesis Firehouse, and then Kinesis analysis, and then Kinesis D stream. So we have three different, you know, stuff available in Kinesis.
Like the
So
question.
Deepesh, so
Mhm.
can I say that these are the three different services, but needs to be picked based on the use case?
Yeah, so we have three way you
You
can transform the data. It's not a three services available inside Kinesis only, but
okay?
based on your, see, you have to use Kinesis D stream in order to use Kinesis Firehouse or Kinesis analysis. D stream the must that you need to use. Um, you know, and then apart from that,
So
you
what
can.
is that in distribution layer you have mentioned Kinesis? So how is that different from these two, Kinesis analysis and Pharos?
Uh, See, if I just tell you, once the data from the kind of, see, first you need to understand. See, basically, once the data has been received via your data streamers, that's generally you used to get into form of shards. There's a producer, consumers are there. So now Kinesis, data analytics, or you can say Kinesis analysis generally. It's generally named as data analytics. So basically, the key feature of data analytic Kinesis analysis is it's enable you to process data using SQL, Java, Scala, or and all. Whereas Kinesis data firehouse is able to easy way to load the streaming data into data lakes and can do kind of a data transformation, comprehension, scaling kind of thing. Whereas Kinesis data analytics is majorly being used for querying the data. Okay, so that is kind of differences are there. Even though Kinesis also add on what I remember is their video stream. So where you can do video streaming data and can do that. So that is how these are subdivided, and based on your use cases, you will be using them.
So is it something that we have to explicitly think about analysis, firehose and all, or else it's just that with AWS, if we use Kinesis, so internally these things happen with respect to analyzing the data and delivering the data.
No, I
How
did not
is
get your
it?
point. What you just said?
See, here you have said so Kinesis analysis, Pharos and all. So these are the services from the Kinesis itself, right? So
Analysis.
should we should we use this specifically for
When you
querying
have
the
streaming
data?
data, we use Kinesis services majorly,
Hmm.
not just for streaming data, but sometimes for batch data also. But majorly 95%, you need to use this for streaming data only, because Kinesis is primarily main for all the streaming data. Okay, so that's why these have now four things. One is Kinesis data stream, Kinesis data firehouse, Kinesis data analytics, Kinesis video streams. So data stream is nothing but it's reading the data based on this any streaming data, and data firehouse is based on ingesting the data, conversion, data delivery. For that regards, it has been used, to the warehouse. For that purpose, the Kinesis firehouse has been created. Analytics is based on how many queries you are doing on the top of it. How many PySpark or Spark query, sorry, Scala queries or SQL queries you are doing. That way it has been prepared.
Okay.
Yeah.
So the glue is specifically for batch processing.
Yeah, Glue is primarily only for batch, where if you have any streaming data, then you can use Kinesis analysis, Kinesis JStream, and then you ingest into Glue.
Hmm.
So you ingest the data using Kinesis, and then you import inside Glue.
So just to make it a batch processing, we are including the S3 storage there, right? Like,
What?
like basically glue is for batch processing, glue ETL, right? And
Ah,
like, for it to work in a batch processing mode, we are introducing S3 storage there, right?
no, S3 storage, yeah, means like when you have a data that you are ingesting from some place, you first put into S3 storage, right? So you can put inside S3 storage. Kinesis is also using S3 only, but they make their own on storage system inside that.
Okay. Okay. So basically, when we say distribution layer and kinesis,
Mm.
so that is a general configuration we need to do there, so that we can route for any, like either for the real time or the batch processing.
What?
I'm actually the in the distribution layer there is kinesis, right? Only
Uh,
kinesis is done. But like
uh,
you said, there are three different type of services:
mm,
systems analysis and firehose, right?
mm-hmm.
This one, which is present in this distribution layer, what exactly this service is, or it's just a general configuration which we need to do, like.
No, this is not just a general configuration. You can use up, see, either you can, remove the whole pipeline for analysis. Okay. You can create your own pipeline. You can create a pipeline like, let's say, if you have a streaming data, instead of getting from Kinesis or anything, just use, after reading data, you are using Kinesis D stream, let's say kind of a D stream, and on D stream you can import or ingest the data either into EMR or either into to Databricks or either into, let's say, call Glue. After doing ETL, and then you can store the data directly into Redshift or either into Delta table. So it's depend like what are the availabilities are there, what is your pipeline, how you optimize your pipeline, what is your usage. So totally based on your requirement, based on pricing, you need to do pricing analysis, right? Yeah, because AWS, all the services are meant for based on, like if I talk about the Kinesis D stream only, Kinesis D stream getting, you need to pay them based on the put load units. Okay. So everyone have their own way of, the way it is being used. So, and you based on your application you have.
So in this case, actually, I was just asking about this case because, like, how do we? But maybe we'll do it in practical, right?
Which one? Well, kinesis is not a part of our, training.
Okay.
So I don't think so we'll able to discuss this. But
Okay.
anyways, we have certain thing that is fixed that we will be discussing. I can give you certain idea later on. Okay, we can have few discussions on the top of it, but this is not the part of our program as of now. So moving further, like we're going to talk about like few services that we're supposed to gonna use. We have already discussed these things, right, related to big data transformation. This, everything we have discussed. We need to create a flexible pipeline from data lake to ETL to the warehouse. We have discussed this part. Now, moving further, we have to, the very first thing that we're going to discuss over this AWS is called S3, Amazon S3. Amazon S3 is nothing but it's a simple storage system. Okay. And we will be going to create S3, right? So we need to build data lake, Amazon simple storage system S3. And, we're going to discuss about what is the storage as a services, basics of S3, consistency modeling, AWS storage tiers, life cycle, these all the stuff. So first of all, you do one thing. I believe let's get open your AWS account here, all of you. Yeah, you can see that. I believe this is the home section of AWS, and these are the services, all services. If you just quickly look into, we have compute services like EC2, Lightsail, Lambda, Batch, AWS Output. Every services are there. For container services, we have these things. These are the services. For storage, we have S3, FF, Glacier, Storage Backway, database, RDS, Neptune, everything. For migration, we have AWS Migration, AWS Snow Family. For networking, we have VPC, Cloud S3, AWS Cloud Map. For developer tools, these are the different developer tools. Customer enablement, these are the different customer enablement services. We have AWS RoboMaker, we have Amazon Managed Application Satellite, right? So these are the services here. Now moving further, we have quantum technologies like Amazon Bracket, AWS Management, multiple services are there, right? More than 190 plus services we have, right? For analytics, we have Athena. Athena is also one of them. Then we have Athena is something that you can also, those who are doing data engineering. Athena is also being used for kind of querying data instantaneously, So like Kinesis data analytics is there. Similarly, you can read or query the data and analyze the data with Athena also. So, on Amazon, you'll find similar kind of services, but have their different use cases sometimes and different pricing model also. So one, those who are aware of multiple services, then that's how he will, even you can analyze your data using PySpark and Spark SQL. Can you see that? And directly you can use an interactive Spark application from here, Amazon Athena. My screen visible to you guys?
Yes.
Yeah. So, like Jupyter Notebook or something that you can access from here. You can directly launch Notebook Editor. You can connect the data from S3 and you can start querying the data from here itself directly on Athena. So, like what I'm trying to tell you that there are multiple services available. We have Amazon EMR cluster. Amazon EMR is one of them that is, allow you to kind of quickly create your own use cases of cluster based on your requirement. Let's say you want to use Amazon EMR, for creating Spark and Hadoop and other stuff. So you can start creating cluster inside this. You can use what kind of notebook you want to use, and that's how you will able to create an Amazon EMR cluster map, Elastic Map Reduce. Then we have Amazon Glue. Is there Amazon Glue is for kind of a that the complete data, pipeline we can create with that. So this is how, you can use multiple services. Then we have Apache Flink. Apache Flink is there, so multiple services are there, right? Now we're going to talk about Amazon S3, uh, yeah, storage services. Yeah. So
companies today need to simply and securely collect, store, and analyze their data at a massive scale. But today's fragmented data storage portfolios force businesses to struggle with complexity and slow down innovation. That's why AWS storage services give you a place to store all of your data with unmatched durability, availability, and scalability. With a reliable infrastructure, tools for compliance, security, and storage management, a massive ecosystem of integrated third-party software and systems integrator partners, and that works with your business processes and even enhances those processes by allowing anyone to securely run queries of their data without moving it to a separate analytics platform. Amazon Simple Storage Service, or S3, lets you collect, store, and analyze data in any amount from anywhere. First, durability. With the largest global cloud infrastructure, Amazon S3 was built from the ground up to deliver 11 nines of durability. S3 Standard Infrequent Access, and Amazon Glacier storage classes store all of your data redundantly across 3 availability zones that are separated by miles on separate power substations and connected to other AZs and the internet on multiple, physically separate fiber paths, keeping data written to a single AWS region protected, even in the event of an entire availability zone loss. S3 One Zone IA gives you the option to store reproducible data in a single AWS availability zone, trading lower fault tolerance for lower cost. And with all of these storage classes, you have the ability to replicate that data to any other AWS region. Second, security and compliance features. S3 supports 3 different forms of encryption and offers sophisticated integration with tools like AWS CloudTrail for auditing. It's integrated with Amazon Macie, a machine learning service that can automatically discover, classify, and protect sensitive data. And it supports the security standards and compliance certifications that help satisfy compliance requirements for virtually every regulatory agency. Highly regulated organizations, like Capital One, say they can operate more securely in the AWS Cloud than in their own data centers. Third, management. Amazon S3 gives storage administrators the most flexible set of storage management and administration capabilities for classifying, reporting, inventorying, and analyzing data. This means you can understand what data you have, make the best decisions about it, and automatically keep your costs down. Amazon S3 also works with AWS Lambda, so you can develop workflows without adding dedicated computing resources. Next, query in place. Amazon S3 lets you run sophisticated big data analytics on your data without requiring you to extract and move the data to a separate analytics platform. Anyone who knows SQL can use Amazon Athena to analyze vast amounts of unstructured data in Amazon S3 on demand. And with Amazon Redshift Spectrum, you can run analytics against exabytes of data in S3 and run queries that span both the data you have in S3 and in your Redshift data warehouses. And now you can even query data directly in Amazon Glacier, making archive data useful without requiring a restore.
Okay, so there are few terms that is being discussing like Amazon Glacier and multiple other stuff. For this, I need to make it clear first of all. So basically, let me just quickly tell you what is S3 and how it is actually helpful for being a data engineer. So Amazon S3 is one of the most scalable petabyte object-based data lake, and it means we can access your data or any data anywhere, anytime. It is same highly scalable, reliable, fast, inexpensive data, and almost 40% of data over clouds are available on Amazon S3. So that's why you can understand like how reliable it is. Amazon S3 storage is independent of a server, means you can access it over the internet. So it is not dependent on the servers because in the cloud environment, right? Data in S3 is managed as object, means continuous stream of bytes. Using an application programs building in standard HTTP verbs, It's object-based, used for structured data, files, images, videos, audios, log files. Very cheap means you can pay only for what you use. No capacity planning required. Used as staging storage for other AWS services well, integrated with other AWS sources. So S3 is very easy to integrate with any other resources or services. Yeah, so that is why it is being used for almost as a data source for almost all the services. And since it's the object based, means you can store any kind of data inside it. It could be a SQL file, it could be a PySpark file, it could be a normal unstructured data. It could be any kind of file you can put inside it, right? So it can able to, upload any kind of file, paraquit file, anything you wanted to do. You can create it as a SDFS storage as well as. So that is why it is more useful. Now, S3 use case, you can backup, store, application hosting, media hosting, software delivery, big data storage, and disaster recovery. So you can use S3 into any one of the conditions. Now, if we talk about durability and availability, durability addresses the question, will my data still be there for the future and how long it will be there? Availability addresses the question, can I access my data right now or how much time it will take to get my data? So these are the two questions that has been, we can actually take it up, right? Now, Amazon S3 standard, is designed for 99% availability zone. So you can see that Amazon S3 is because Amazon S3 is created in such a way into their entire global regions. So if there is a loss in a data, it is multiple it's such a architecture that is available and will do a disaster, even though in disaster, if it's happened, it recover it, that kind of architecture they have created. For example, if we store 10,000 objects with Amazon S3, we can expect a single loss in more than a 10 lakh years. This is how they claim, right? Amazon S3 have different type of services inside that. We have Amazon S3 standard. We have Amazon S3 standard IA. IA stands for infrequent access. We have Amazon S3 one zone.
Sorry, can you go back to the previous slide? I did not understand that numbers.
Yeah.
What do you mean by that if you store 10,000 objects?
It means, let's say if we store 10,000 objects with Amazon S3, the loss of the data, because of the hard disk or because of any kind of loss between the objects can happen, in every 10 lakh years.
Okay, maybe you can take this up later. Yeah, go ahead. Yeah.
Yeah, so I was talking about storage classes. So Amazon have Amazon S3 standard. Amazon S3 standard stand for general purpose frequently accessed data. Okay, means let's say if you have any data or any application that is using a frequent use of data. So here you can use a general purpose frequent access data here. Okay. Amazon S3 standard means infrequent access of data, infrequent access of data are there that you can use that. And, like we have Amazon S3 one zone. Amazon S3 one zone is for infrequent access. Let's say you don't have any infrequent access and you actually access data after certain interval of time. And that is why it is also cost effective, so they have the less processing required. Then we have S3 intelligent tidying, Amazon S3 Glacier. So these are there.
So,
If we talk
Dipesh,
about,
Can you? Okay, are you going to talk about this in detail in this slides? Okay.
Yes. So as I mentioned, Amazon S3 standard, Amazon S3 standard IA, Amazon S3 one zone, Amazon S3 intelligent tiering, Amazon Glacier. So we have varieties of data, right? And every varieties of data have their certain purpose. Okay, and why we have to use what kind of data in what condition, we can actually look around it. So when we talk about Amazon S3 standard, Amazon S3 standard offers a high durability, high availability, low latency, and high performance object storage for general purpose use. Means when you have a data that you accessing very frequent, like your PySpark, like your, anything that is in an application, you have to create a kind of a interface where people are accessing objects and analyzing something. So those kind of places where you can, use this Amazon S3 standard, right? Now, Amazon S3 IA. IA is means infrequent access. This is similar to standard, but like let's say you have infrequent access means lower per GB month storage cost than standard it will get you. Uh, you know, Minimum retention period is 30 days. So for this retention period is like, let's say if you put the data, the retention will happen in 30 days only. Minimum object size you need to put is 128 KB. Retrieval charge based on per GB retrieval cost. Okay. And then best use case is to, suited for infrequent access data that is stored for longer than 30 days. Okay. That is how we use this IA data. When we talk about RRS, reduced redundancy storage, Amazon S3 offers this RRS, means it offers slightly lower durability than the standard IA. It reduces cost and it is most appropriate for non-critical data or derived data that can be easily reproduced, such as image, thumbnails, those kind of thing, stuff. Also, we have a deep archive storage, the one that is we use for archive, the one that is like as a backup file we use, long-term backup file we use, then we store the data into Amazon Glacier. So Amazon Glacier offers secure, durable, and extremely low-cost cloud storage for data that does not require real-time access, and that is used for archive and long-term backups. Amazon Glacier is optimized for infrequent access data, where a retrieval time of several hours is suitable. So retrieve one Amazon Glacier object, you know. So these are certain types of, S3s of, services are available. So if you have any questions, you can ask me on this.
What is
Deepak,
4 nines?
What?
4 nines offers slightly lower durability 4 nines.
I think that is in the previous slide he had shown, right? 10 lakh years. So in that,
Right.
1 lakh is less. That is what it is meaning, if I'm not wrong.
I'm not sure about this part, but yeah, means lower durability.
So I can tell about it. So what S3 says is that the durability is 99.9999%, right? So your data
Yeah,
will be there
4 9.
in,
Yeah.
yeah, I think 7 nines, right?
Oh,
7 nines
okay.
are there. Total 7 nines. After 9.9999, right?
Uh,
So there are 7 nines, right? So that's the durability that your data will not be lost, right? But if you choose Amazon S3 reduce redundancy storage, right,
they come to
as a
4 9.
storage option, then your 4 nines will get less, right? So your durability percentage will be 99.99%, right? So there is little bit more chance of very less more chance that your data might get lost or something like that. So yeah.
Is it going to be 99.9999 or 99.99?
99.
Uh, that I'm not sure. Can you go back to previous slide? Let's count how many nines are there.
It was
Okay, yes. So it's
1, 2,
1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so they are totally 11 nines, right, including 99 point also, right? So we
Yeah.
can decrease 4 nines, so it will be like 11 minus
99.999.
yeah, we know that.
Okay, no worries.
Yeah,
Yeah.
so we can like you can reduce last 4 nines from this thing, right? So it will be 99.99999%.
Dipesh, I have one more question. So now we are building we are storing data in S3, right? Initially in a standard storage, right?
Mm.
And after uh, after maybe 6 months or a year, I feel like okay, some data should be moved to Glacier. So
Mm.
is it possible to do it in a programmatical way, or something like configure schedule that okay, if
Yeah,
any
yeah.
data is
So
getting
how
this
it happens?
old.
Yeah, so
Mhm.
basically, let's say you are using PySpark or Databricks, you need to mount your data storage, right? Like which bucket you are using, right? Now, while you're creating a bucket, while you're mounting it, okay, there are certain access you have, okay, of all the services that you're using. Let's say you have ingesting the data, like the ingestion is happening inside your frequent access, means your standard data, right? Once you store the data, now you have taken up, you did some ETL, and then you stored as a Paraquet file inside, let's say called Glacier. So if you want to store the Paraquet file inside Glacier, then you can mount that Glacier bucket inside that, and you can store over there. That is possible.
So is it that the Glacier S3 is different than the storage
Yeah, yeah.
S3, or the same storage S3 will be converted into a Glacier one?
No, Glacier have a different, like service. If you see that here, if you see S3, Glacier is a different service.
Okay.
Can you see that? It's archive storage in the cloud. So you need to, well, then IA or S3 having IA in frequent access. But when we come across S3 Glacier, S3 Glacier is itself a different service. One Express John, multi-region access point, create vault. So when you search on S3, you will get multiple services of S3. You see that. These are the yeah.
And
So
then how we can reuse the data that is stored in Glacier? Like now I have stored something
you
in
can again
Glacier
access it.
S3.
You have again access it.
Mm-hmm.
You can actually access from Glacier. So but the only thing that Glacier will take is time. So let's say when you are accessing data on S3, it is to instantaneously available, right?
Mm-hmm.
Whereas in Glacier, if you're accessing the data where it's stored, it takes time. It can take up to hours also based on your requirement of your data. Just allow me 1 second. Huh?
Mayur, adding on to your point, right? There is something called as lifecycle rules and
Yeah.
replication rules in Amazon S3.
Mm-hmm.
Okay, so imagine after 2 months you want to put it to Glacier or you want to put it to a Parquet file, you can just add that as a job over there, and it will as a rule over there, and it will automatically transfer it based on that.
To the Glacier, right?
Yes, it is also to the Glacier. And also in Glacier, you have again, if you want to take it out from it, right? There is a other service or other ways to actually implement it so that you can put it back into Redshift or S3 back.
Yeah.
So
Okay.
basically, companies use these methods to not to overburden their S3, but to keep for historical data in the Glaciers. Like after 5 years, I don't want this client data to be on a certain S3 buckets. We just pass it on to Glaciers as a long-term storage.
Okay. Thank you, Asu.
Sorry, I was on mute. You have asked some question. Can you please, again repeat? Hello? If you're asking something, I missed actually. I just had to take a call, so I just quickly mute that. Can you quickly repeat what was the question?
The question was like after moving the data to Glacier, right? After
Mhm.
again, I want to reuse. So what will be the process? Like, do we move the data out from Glacier to again the standard S3 and then use it, or we have to directly access it in Glacier?
No, 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 no. See, you need to understand why you want to put into the Glacier. So let's suppose if we have a scenario, let's say I just give you one scenario. Let's say there is a company called Zomato. Zomato, the, like they have, let's say, called 10,000 uh, companies are associated with them for onboarding. Okay, but that is possible that there are thousands of restaurants got closed after 1 year, right? Now, why they are supposed to gonna, put it for frequent access of those data? Of course, they wanted to get it verified. Okay, some kind of their, let's say, name they can put on, in their frequent access data or infrequent access data. But their images and all those stuff, they wanted to put into Glacier or later on, let's say if those company came and they wanted to onboard again. So they should have those data are available that can be retrieved. But I know like this data is will take time. So based on my uses, I know when I want this data or what kind of types of data I can put inside it. So that's how I will access it. And if I feel like, yeah, with this particular data, I need to put it alive, then I can shift that particular, like object of data inside the S3, frequent access.
Okay.
Yeah. So this is what so here like all the types of datas are there, deep archive data. Yeah. So based on the cost wise, standard is like highly you need to pay much than standard IRRS and Glacier. And retrieval time, of course, Glacier takes very much time. And then then others. So accordingly, it is there. Now, bucket, like when we talk about, like uh, our store, how to create a bucket over there. So let me just tell you how you can.
Dipesh, this retrieval time is purely based on the volume of the data, right?
Volume of the data and time of the kind of uh, services you have used. Because let's say if you have using the frequent access allow you to access the data in a very faster way rather than other one. So Glacier, even if you have a less object, it will take time. Okay, and if you have a very high much object inside S3, it will take less time. So data and the type of services you're using, based on that you can classify the retrieval time.
You mean that frequent access, the data is cached there and here it is not, something like that?
What?
For the frequent access, the data is cached and it retrieves the data from the cache as well as, but with the glacier, it's not the case. Just trying to understand why the retrieval time is more when it comes to Glacier.
Uh, I'm not sure about it, like, but the architecture of S3 is like in a such a way that I need to quickly, based on the availability zones, it is there. So let's say if you're using S3 and if there is and again, it is also been experienced based not just on the one cache and all, but based on the like the server you have deployed your data. So like when you talk about the use case that is available inside Mumbai or Oregon of US, Ohio or something, that's how it will also can take time. So it is also one of the availability zones. And then how do you have which availability zones you have taken up the data. So that is how things happen. And I'm not sure about the exact architecture right now, but yeah, I mean, I can look into that and I'll let you know.
Sure. Okay, thank you.
So in Amazon S3, we have certain things to be discussed. One is how to create a bucket. So basically, in Amazon S3 is a service. Inside this, they have named to store your data. We create a bucket. Okay. So bucket is what in S3. Whenever in S3 you will create your data, you can upload any kind of data inside it. But the one in which we'll upload, that's called bucket. So Amazon S3 having a bucket. S3 where will you store your data? Each bucket on S3 have a unique name. Unique name, when I say, it is totally based on the global region. So let's suppose in a New York, if somebody's name is called XYZ and he named XYZ, in there, and you are sitting into India in certain location, you cannot name the same. Your name should be, the unique representation and identification required for that. Okay, the very unique bucket name need to be there. Okay, so that is what the first thing about a bucket you need to know. And it is across all Amazon S3. Again, Amazon S3 block all public access to your bucket by default. So by default, all public access are there, default blocked. You need to give access based on your requirement to whom you want to give access, the who's which services of Amazon you want to give access. Or let's say if you are using pandas and you want to give someone else access, so you need to give that. And how you give access, let's say I have a S3, okay, Amazon S3, and I have certain Excel file inside my S3 and I want to give access to someone who is using pandas. Okay. So how pandas or Python, or let's say you're using any application, how they going to access it? So to access this, the process there is called IAM inside AWS, that's called identification authentication management. Okay. So IAM access, you will allow, they will generate a secret key and password or something like that. Based on that, you can actually access those, buckets, and you can give the access to someone else. So that is what how you can actually give them access, and it's use object lifecycle management to control object life. You can put version control, prevent accidental deletion updation. Means let's say I will be discussing on that, but let's say you have accidental deletion, so you can create a version control for backup and all. So it use one or more bucket, cannot be nested. It use access control for each bucket. Now, what is object? So inside bucket, when you upload your data into form of S3 object. So Amazon S3 store data as object within the bucket. An object is a file and an optional metadata that describes the file. Okay. To store a file in Amazon S3, you need to just upload it to the bucket. The maximum object size is 5 TB in particular one object file. Okay. Then you can actually uh, install any other, you can create another object, another, bucket, and then you can install. But maximum object is 5 TB you can put. It support types of file: CSV, JSON, paraquet file, ORC, Avro, fraud buff, images, multiple things, text, IPYNB, multiple types of file it's actually used as. When we talk about the life cycle management of S3, when you apply it on a bucket but implement it on object in the bucket, used to manage object in a bucket to store the most cost effectively throughout their life cycle. I need to show you like how these things happen. So for this, you just go here and just search Amazon S3. And when you go into S3, Yeah. So there is an option you'll get to create a bucket. So when you are creating a bucket, yeah. So we are using a general purpose. Okay. General purpose, like configuration we are using. You can name it and specify your bucket name. Okay. So either you can copy, there is an option you're getting. Let's say if you have already a bucket and that bucket you have made some certain settings, you can use those settings to create the bucket, management stuff. I'm just naming, let's say you can name, let's say call lab pop Dipesh new S3. Okay. So this is my bucket. And like then you're getting object ownership, so basically it control ownership of object returned to this bucket from other AWS account. So here, if you wanted to get the ownership from other ACL account and all, that's how you can enable it. But ACL by default it is disabled here. Now moving further, by default, as I mentioned, all public access setting for this bucket is disabled. So here, if you just unchecked it, then you can give block public access to bucket and object granted through new access control list. Block public access bucket and object granted through any access control list. Block public access bucket object granted through new public access point policies. So here you can define this, like you have defined this. Then bucket verisioning. Bucket verisioning is what? Bucket verisioning, when I mentioned here. So here, verisioning is nothing but it's protect the data from accidental deletion, overwrite, or application failure. Keeps multiple variants of an object in the same bucket. By default, S3 verisioning is disabled in bucket, right? So when you do verisioning here, it's by default disabled. If you enable, it will create a backup file, right? Tag, like if you know tags means you can define a tag. Let's say we are doing a Apache Spark, tag, or we can create a tag based on that. All our in tag section, when you search all our, let's say you are working related to pipeline related to data engineering on Databricks. So you can define this, that this is my tag and that is how I am using it. So you can define this. Then we have default encryption. Encryption is what in S3 is, like by default you have, Amazon 3 based managed encryption is there. So that's called server side encryption. So encryption is that is by default of Amazon S3. If somebody's have their KMS, means user have their own authentication management system. So that can also be done here. So we have these three different encryption process. SSE S3 encrypt S3 object using key handled and managed by AWS. KMS use AWS key management service to manage encryption key. Additional security we can add. SSEC is you want to manage your own encryption key. So that is how the different encryption is there. Then if you go to the advanced setting, store object using write being overwritten for a fixed amount of indefinitely disabled, enable. Yeah. And then you can create bucket. Oh, just remove it. I don't require it. Oh, create where secret permission is required. Are you able to create? Hello?
No, we haven't tried.
We haven't tried it.
Please try this.
Getting same error. Failed to create bucket. Create bucket permission if required.
For me, it worked. I was able to create.
Yes, I am also able to.
You'll be able to create what?
Yes, I am able to create.
Why I'm not?
It works for me.
US East.
Me too.
Okay.
So it's saying that you don't have IAM role permission to create the.
Can you change the location to Virginia and check?
Okay.
Yeah, it's maybe US East we need to check. US West.
US East, huh?
Ohio.
West, East, North Virginia.
Okay, maybe they have the lab vendor has given this access on US East Virginia. Yeah, so our bucket is here now. You can see that. This is a bucket. And now we can actually upload our data here. Let's say you have an Excel file. So you can add files here or you can create other folders. Let's see here. This is something we can upload. Let's just upload. So you can see that file has been uploaded here. And this is your file. So here diabetes.csv is there, and then you can actually anytime use it. So this is a URI number, and ARN, the size is 23.3 KB. Object URL is this one. Okay. And you can enable bucket horizon, server-side encryption settings if you want to edit additional checksum tags, metadata, text CSV object lookup. So these stuff is here. And yeah. Now, anytime if you want to use this S3 on any other place, any other place, you can actually use it. So let's say if I ask, okay, I will be discussing that part. So first of all, this is how we are able to access our data. Means this is how we created our data, and this data we can use into other services also. Even, let's say you can upload images data and you can ask other, services to get it used. So this is the idea, like this is how we can actually create it. So please have a look if everybody can do that.
Deepesh, can you say that what's tag mean here?
Tag is nothing but, like giving, let's say you have a date, you give a data engineering tag here, right? So let's say I'll just show you. So you have this. Sorry. Tag. So basically, tag is nothing, but it's kind of a, yeah, here it is. So here you can define that we have a tag, and sorry, I wanted to give they call data breaks related we are working, and this is S3 bucket data, right? So basically, when you save changes here, and let me remove this. So I know that I'm working related to S3. Okay, I'm working related to S3, and anytime, like I will be searching, like S3, just a second.
Okay, you reference the tag.
You reference that tag. So that is how, it will able to kind of, help us.
Okay.
One more service that is, that we need to look into that, and we will discuss around this AWS EC2 as well as. So Amazon EC2 is one another service that is, very much, like as a, like you could have used it, and you can deploy your different other Spark services on the top of it. So we will also discuss a bit on Amazon EC2. So let me just help you with that as well as. So let's suppose, first let me just quickly discuss with you. Let's say you are not willing to use AWS, uh, you know, Glue or AWS Databricks, because Databricks is very like it's a costly, if you're getting costly for you, and you wanted to manage by your own, right? So when you have these kind of problems, when these kind of scenarios are there, you can create your own virtual machine, and you are paying for virtual machine and the computation you are using. Okay. So Amazon Elastic Cloud Compute is a web service that provides secure, resizable compute capacity. Okay, so you can do computation based on your requirement rather than having another source of integration on the top of it. You can have your own requirement on that, and that's how you will be able to use around it. So yeah. So basically, when we talk about EC2, right? So EC2 is one of the kind of services, that is allow you to create computation. You can create your own compute service with that, right? And in EC2, we have different types of, instances you can create. A virtual server you can create, like the virtual server we created inside a machine. We can create a virtual server inside that, right? And you have AMI, Amazon Machine Image. So Amazon Machine Image is something, means different kind of operating system you can deploy. Let's say you wanted to deploy Windows, you want to deploy Linux based system, Ubuntu, you wanted to deploy any other Mac OS platform. So any platform you can install, and on the top of it you can install your machine. Okay, on the top of it you can install your applications, right? So in EC2, so there are different types of instance types are also there. Instance type means you can install, you can use general purpose workload, T2, T3, M5. You can use optimized computation stuff, memory optimized one you can actually install on the top of it. You can have your, accelerated computing, means like how much leverage of computing you require, that you can also use that. Okay, so these kind of things that you can use that, and based on your pricing model and your storage options. So here also you have different types of storage options are also available. So when we talk about different storage available, so here we have general purpose SSD, general purpose block storage, and these kind of throughput optimized SSD or SSD GP2, GP3, these kind of options you will get here. Okay. And you can create your own EC2 machine over there. So I will be going to tell you, we are not supposed to gonna talk about in detail about EC2. Rather, we will be installing Spark on the top of EC2 by creating a Ubuntu machine. So what you all need to do that is, you all will be performing with me to create your own EC2 machine. Okay. So for that, there is a process that I have already instructed. Just a second. Here, let me open it. Yeah, so you can see that I have given the complete steps what you need to do in order to create your Jupyter notebook like Databricks we have. You can actually use Jupyter notebook or PySpark. Are you getting my point? PySpark you can install inside it, and you can start using your PySpark functionality here itself. Okay, so here itself you can start using the PySpark functionality, and you can actually look around it. So we will be installing this on EC2 instances, and we will be creating this. So there is a complete process has been there. I will be sharing this with you, and I will be also going to I'll going to install here just to I'm giving you so that anywhere you find difficulty, you can use this. So just a second. Yeah. Okay. So let's install Jupyter Notebook. Did you understood what is the idea? We will be installing Jupyter Notebook. Okay. And we will be creating a virtual machine, Ubuntu based Linux based platform. On the top of Ubuntu, we will be installing Jupyter Notebook, Spark. Okay. And on after installing this, we will be writing queries on Spark by using Jupyter Notebook. This is the idea. Like we have Databricks. So Databricks are also been created in such way, but that is a different case. But we can use without using a, let's say if somebody wanted to use a Spark feature, a Spark functionality, we can directly use it inside it. Did you get the point?
Why do we need Putty for this?
Putty is something just to access the the user interface of Ubuntu, but that's not required. We can directly use AWS UI. So I will be showing you how you can do that. You can just keep this notebook only and just search here EC2.
So now we create EC2 on top of it, Linux OS, and then Jupyter Notebook, then
First,
start
just
writing PySpark.
confirm me in the chat box, all of you. Did you understood the objective? Yeah. No. Nilesh did not answer. Nilesh, what's the doubt you have? You can ask me. So the idea is that
Dipesh, can you please repeat that last part?
see what we have. We are willing to do that. EC2 is a compute service like virtual machine. Okay, so we'll be creating a Linux-based virtual machine. Okay, and in Linux-based virtual machine, because Spark, can be installed inside Linux-based environment. So in Linux, we will be installing Spark. Okay. And we will be also installing Jupyter Notebook so that we can access, you can use the Spark prompt in Spark PySpark queries on Jupyter Notebook, right? And we can create a Spark cluster, we can do all those stuff. Did you get the point?
Yes. Okay.
Good enough. So here, once you have it, now we will be going to create a instance. Okay. So in order to create an instance of EC2, here is the instances. We have different, if there is any instance or not, you can do that, or you can, types of instance you can create here. Okay. So this is the types you can create that. So well, this is our EC2 dashboard. Okay. We can launch instance, means we are creating instance here. So launch instance here. So while you're launching an instance, okay, there is a new user interface is there, or you can actually, where it is. Oh, they've removed the old user interface. They changed the user interface. Generally, when they do, they keep the option to, go to the old user interface. No worries. Just name your instance here. Let's say you can type PySpark lab core. Okay. Here is my instance name. Then here I will be installing Ubuntu. Okay. And since you can use any one of them, see, it's a free tier eligible one. T2 is small and something like this. It's a 1 GB memory, T2 is small, T2 micro is there, 1 CPU and 1 gigabyte memory is only there. Okay. Then we have, like multiple other one is also there.
Any particular reason for selecting Ubuntu or others?
Ubuntu, I told you, Ubuntu is Linux based platform, right?
Mm-hmm.
Yeah. So on Ubuntu, you can actually easily able to install, because Spark is going to be installed inside Linux based environment only, right? So for that reason, I have taken up this Ubuntu.
Okay.
If you take Windows, then again you need to create a virtual machine inside that, and then you will be able to install. So it is bi-directly again and again inside create. That is the idea. So basically, as I mentioned here, this is I'm using Ubuntu based server, and here I'm using this T2 micro only. Okay, so this is again T2 micro. It's okay for us just to see. We are not supposed to gonna work on this. Just kind of we'll be using that. That's all. Now here, uh, key pair login means, like, let's suppose if you have Putty and you want to access, the virtual machine using Putty only. Okay, so you can create a new key pair, or if you have a previous key pair, you can use that. So if you want to create a key pair is nothing but it's a kind of a accessing, encrypted way to access your, like your the virtual machine, within some environment. So for that reason, you can use either, you can create a PUM file or PPK file. So PUM file is for OpenSSH and PPK file is for Putty. Okay, so you can either create, let's say, called my PySpark file. So either you can use PPK file or you can use Putty directly from here. So when you create a key pair, once you create a key pair, that this has been downloaded, my.ppk file. When you open using Putty, you can directly able to access this virtual machine from there also, right? But we can access directly from their AWS instances launch. So from there, we can also access it. Then again, it is asking us to create a network setting. Okay, network setting means, let's say while you are accessing this from your browser, you want any specific IP from where you want to access this. So those settings are there, right? So here I want right now, since you can use custom IP, my IP or anywhere. So I keep it anywhere so I can browse from my browser. Okay. I can browse from my browser by giving the location. So here, if you can see that I have kept this from anywhere. So while I'm just putting this, so here you can define. So I keep, just a second, the here, I put this anywhere, right? So here, you can actually similarly, you can keep this anywhere as of now, or you can define your existing security groups if you have. So if you have any existing security group that you can also define. On the top of it, we can, since we wanted to use the TCP layer protocol, we will accessing it. So we will add on the top of it, but not now. Once you do that here I have done allow SSH. I have taken this configuration is 1 into 8 GB, GP3. GP3 is SSD based drive. Okay. And right now we're not keeping any advanced IP access to a domain join directory or something like that. These are not we are enabling it. And then I'm just keeping to launch the instance. Yeah. So the instance is going to be created.
So Dipesh, you have launched this instance without key pair, right?
Without?
Key pair.
Without key pair. No, key pair we have downloaded already.
Okay.
Now,
Okay.
if you want to access this key pair, you wanted to access this virtual machine using putty, you have to browse that key pair file and you can directly access using putty only.
So we will be using putty today or only UI?
No. We are not using any putty as of now. We
Okay.
can directly launch the instance. I'll show you. But
Okay.
before I launch the instance, okay, there is one setting we will do about security because once you do that, then like you can apply some security group, because security group is if we have to apply certain security group for incoming and sending the data kind of thing, for that reason we'll be applying. So here, here if you can see that in this, here is a security groups, right? So we are going to create a security groups and we'll apply on our instance. Okay. So here there are certain security groups has been created on EC2. We'll be creating our own security group and we'll apply on EC2. Hello, are you getting my point?
Yeah, Dipesh.
Now, to create this, just click on create security group. Yeah. And here, see, here we have to create my group I mentioned, and VPC is let it remain same. And just you need to put inbound and outbound rule. Inbound rule, the security group right now does not have any inbound rules and outbound rules. So inbound rules, just to we can choose add inbound and outbound rule at the time of creation. You can add them. So the protocol to allow, this is just to allow any specific from any browser. For that reason, we are using it. So for add rule, we are doing here all traffic, and anywhere, IPv4, okay, and anywhere IPv4, and this is what we got. And you can, if you want to put any description, it's okay. Otherwise, it does not require. Similarly, for this, this is the security group we have created. Allow, just name it. Yeah. So we have created the security group, right? Now, once we go to the security group, then here is your, this is your instance. Yeah. And on this, just do a right click and go into here you'll get like security groups, and here you got this change security groups. Okay, change security groups. And here you will, when you browse, we have created this my group, right? This my group, right? I just browsed it and I add this security group here and then save. Are you all here?
One question, can we create mutual exclusive security groups and apply both of them to the instance?
Which one?
Let's say I create one security group where I allow inbound traffic, and the
Mhm.
security group where I do not allow inbound traffic. Okay, I associate both security
Based
groups
on
to
your
the.
requirement. Yeah, we can apply on this. We can create two different security groups,
Mhm.
and we can have inbound, even though in the same inbound rule and outbound rule can be changed. Your inbound process and outbound process can be changed.
Okay, so while accessing an instance, is it the case that there will be only one security group will be applied?
Means I did not get your point.
Can we apply multiple security groups?
Yeah. You can apply multiple security groups. Here, let's say if you go into security, and if you have more security group, you might have created more security groups. So you can browse and just add it. So you can have multiple security groups. One security groups that Amazon is managing. Can you see this?
Mhm.
And one that we have created. So, that is always there. You can add multiple security groups. Yeah. Now, here is your instance, right? And if you wanted to, like terminate, reboot, everything is there. Or if you want to launch the instance, okay, just connect here. Yeah. Connect. Now, this is again going to ask you, connect using EC2 Instance Connect. So there is a direct way to connect EC2 Instance Connect. So if you connect using EC2 Instance Connect, this server going to be invoked. And you can start, this is your, user interface of Linux. This is your user interface of Linux. Yeah. And by default in Ubuntu, Python is already installed, Python 3, and you can start writing the Python program. Yeah. So now what we're going to do that, since the Linux, this is the environment. Now we will be going to install a few things that's I mentioned here. You can see in my, docs, here you need to have, like you need to install certain required necessary packages to access Jupyter Notebook. Okay. So here I will be going to, I have taken up here a file, just a second. Okay, let me take from here itself. So let's say if I willing to take the data and wanted to paste here. So let me do this nearby. So it will be easy for me to access again and again. So first of all, see what we are doing is first we are going to update. So we're going to update the, our Linux, and you know Linux, if you know that we use sudo apt-get update, right? So it got starting updating. We need to install the necessary packages. Like we are going to install pip. You know pip, why we use pip? Anyone here? Pip
It's
is
a package
Python
manager for Python.
packaging. Python import packages. So whatever the packages we require to install related to Python, this you can actually is able to install. And this is possible that maybe some of the commands may be depreciated. Sometimes it's happened. So yeah, then okay. So now I'm installing this pip. Why? Please follow me, guys, all of you. Are you all on the same page?
Yes.
Then we need to install also Jupyter.
Dipesh, can you show that pip installation?
Yep. This I already given to you guys, right?
Okay.
If you see in the documentation here in the last, I have already given all this steps.
Okay.
So now we need to also install Scala. Why Scala? Because Spark is written in Scala only. So to support this, we require to install this as well as. Right? Then we are installing Py4j. Anyone having any idea why we are using Py4j? Hello?
Yes, it is a Python for Java, means it is used in
It
Spark.
is a connector between your Scala and Python. Okay. Since we wanted to interact in PySpark, so Python plus Spark is being as a connector in the source that will allow us to, it's a kind of a API that will allow us to communicate with that environment. So Py4j is the one that will allow us to do that. Py4j also not able to install by apt install Py4j. Yeah, just click on this launch stance, or you can go on connect. Connect also there is an option. Yeah, just on this, just below there is a launch.
Connect, right?
Yeah.
Okay, I'll start installing the packages. Okay, thanks, Dipesh.
Yeah. So we have installed this as well as. Let me just quickly, like uh, do once again the check the PI3 sudo cd get install Python 3. Why? Already Python is installed, but I'm just quickly checking this is already done. Python is manually installed. Okay, then Python 3 PIP also is there, but again, let me check. Use Python already installed. Now let me check PIP 3 install 5 okay. Okay, let me check the way we have installed this. Let me install the other one, then have a look. Why it's not getting installed. Now, these are the dependency. Pi 4j still has to be done, but we need to first get to update the Hadoop because Spark is running, so MapReduce and distributed file system we required to use. So I'm just going to use this first. Let's download the Hadoop from this link. Okay. Once you do that, it is saying installing. So this is a zip file. So once you do that, we will be going to sudo tar. So unzip can be happen. You can see that. Just unzip this. Once you unzip, then you need to install find Spark so that like when we going to access the Spark over Jupyter notebook, so it will help us to access it. So it will able to help us to find that. For that reason, we are using find Spark. Why this is happening? So PIP3 is what's the command? Sudo
It's sudo apt
uh,
install pi4j or what you're installing.
I guess we need to reinstall pip3 because we are not able to install anything using pip3, and this command finds it in the local system maybe.
correct.
Yeah, Nikhil, is it working? You are using pip here only, right?
Yeah, it's working. I just did that.
You are using pip only.
Yeah, I'm using for it.
Okay. So this pip, okay. Let me check.
It's actually worked for me.
We're using this command.
Yeah, pip install pi4j break system packages.
What is the point?
Actually, that will break any system packages inside.
That will.
That will break AWS inside systems packages as in restrictions, anything. That will break and it will reinstall everything.
Okay. 5.4G installed. So I think this should also get installed now. Then find a Spark. And Yeah, this will also get installed. So all the necessary package that we required have installed now, right? One more thing left, that is called notebook. Let's see if this can download, this can install notebook or not. Okay, the same problem. So here, okay.
I guess instead of pip3 we need to use pip, which will work.
Pip.
Only pip.
So well, anyways, we have installed all the necessary package now. So now what we're going to do that we have to create some configuration to use Jupyter Notebook. Okay, so here cd, and we need to create a directory. We are going to create a certificate for this. So we're making a directory called certs. Please make sure you all create in the same way, because sometimes it's confused when we write the. So basically we are creating a certificates so that we can access the Jupyter Notebook, right? Then we will go into this cd certs and cd certs. Yeah. So here, once we go here, like now we're going to mention some password. So and some kind of a, a license, or you can say the certificate we are creating for this. So for that, we are mentioning this, right? So here I'm going to add the sudo and open SSL request nodes 365 new key RSA 1024 key of my certs pom.out. So here it is the, like the kind of RSA we're going to create to access this.
Access what?
What's happened? Yeah, so basically, when you use Jupyter Notebook, you wanted to access inside this, right? So in order to access Jupyter Notebook, throughout this node, so this Jupyter has, this open SSL, it has to request from the local server. So for that, this is the RSA and kind of to access it. Okay, so we are creating my cert.pom. Okay, this is the file by which we'll able to access. So this is your cert, my cert dot pom file.
I can make a connection to Jupyter, that's all.
Correct. But it's saying this.
No, that after that out command is there, or there only you have to give that file name, that mycert.pem.
Oh, yeah.
It is one command. Yeah.
Yeah. Now you can mention, your code name, location, whatever you wanted to mention, your address, everything you can mention here inside that. And we'll put in the charge. So here I can keep my, this, you can put anything, and you can put a state name. So I'm keeping it blank. Yeah. So you wanted to check like if, so just check this if it is fine. So here you can see. One root mycert.pum is here. Can you see that? Yeah, mycert.pum is it created. Now what we're going to do that is we have to, like going to config this config Jupyter notebook in which, there are some certain configuration we need to apply, like because we wanted to access the Jupyter notebook and we wanted to access basically this mycert.pum on certain port number. Are you getting my point? Because if you see, when we opened the Jupyter notebook on Anaconda, so it was opening in a local web browser, right? So in order to access this, we need to make some settings for that. So here, you need to reach out to this first. Go to the Teams directory, then this copy and go reach out into the Jupyter notebook we have created. Yeah. Then we can, since we are into this Jupyter notebook, now we're going to go into VI Jupyter notebook config.py. So here we will be, so now you can see that now it will allow us to access. Okay. So when you press I, okay, you will be able to, when you press I, then you can actually enter it. So press I. When you press I, then you will be able to mention your, configuration inside it. So here, let me do that. Yeah, so here it is the config. We can actually do configuration here, right? If you want to do configuration, it is the point where you can do configuration. So what configuration we required to do? This is what the configuration that we required to do that this is your home Ubuntu search mycert.pum it will access, and the notebook app.ip and browser open browser here false, a notebook here it is integrated. So this is something that is going to be open and we need to mention this to here, right? So you can see that we made this location applied here, right? So once you do that, we have made some kind of a changes. To exit this after escape, you need to type this colon WQ so that we can, like come out of this, configuration. So here.
It's actually escape colon WQ.
Yeah, right. Escape colon WQ exclamation enter.
Yeah, we are out now. Yeah, so we made some changes over here. Now just change directory, AD, and then you have to do one loop back IP because this IP will not work. So what I mentioned here is this one. So, when you try to using direct Jupyter, when you run this Jupyter notebook, so it may cannot work. So rather just use this IP. I'll show you. This one. So Once you do like no browser and notebook IP, it will give you one IP address. Just paste this IP address here and hit enter. So once you hit enter, you can see that there is a IP address has been given to you, right? This IP address HTTP 127 something like this. This is the local IP of your Jupyter notebook that it is opening. But we need to open this in your external browser. See, here there is no Chrome or anything is installed. So we wanted to access it into a local kind of browser. So here, if I wanted to access, I just
You mean over internet?
yeah, on internet. So if you want to access this, you need to have your this EC2 instance IP address. So I will be going to this is my EC2 instance. Open link in new tab. Yeah. So for that, this is my browser. Just do not close this. Just do not close it, otherwise it will not run because it's running right now. And here is my, where is my instance? Instance is here. And this is my instance ID. This is my IPv4 address. IPv4 address. I will paste this IPv4 address with this notebook. So this notebook is supposed to gonna run, but on this IP. So I am able to going to access this on this particular IP address. What happened? Permission denied. Right? Is anyone able to access it? Oh, just a second. Wait. Then it will going to open a Jupyter notebook. It's saying permission denied. If you are able to access it, anyone? Just copy this.
So I was pressing.
Section while loading config file. Jupyter notebook config.py. There are some problems. This is something there is a problem. Anyone able to access?
Yeah, Dipesh, I am able to access.
How many of you are able to access? So you have done the same step, right?
Yeah.
Where are they? Okay, can you share your screen?
Yeah, Dipesh, are you able to see that?
Yeah. So this is what the Spark Jupyter notebook, right? So now if you want to run a program, can you just share your, can you allow me to write on your screen? Just get the permission.
You can refresh.
Your screen, right? No, I'm not getting any permission.
You are controlling Dipesh.
I'm
I
controlling.
have shared. Yeah. This mouse, yeah, you are controlling.
Okay. Here is the Python 3 notebook, right? So now, if I have to slide here, little bit, slide in the middle, yeah. So here, like, see, if I wanted to confirm where everything is working fine or not, so here what we can do is, we can write kind of a file where, it will, first I will be going to do what, like I will import. See, if I import here directly PySpark, it won't understand. PySpark, it won't understand. So here, it will not understand. No module name PySpark. So for that, we need to import here, import find a Spark. Okay. And then we need to find a Spark from the location we have here, we have installed. Find Spark dot .NET. Okay. And where is the location? On home section we have taken up, right? So on home we have installed in Ubuntu. Okay. Can you just paste here?
What I need to paste?
The
In the paste?
location, I think, that we have given on the top, home Ubuntu. Okay, just a second. Let me write here only. So Ubuntu / Spark, that the file name is 3.0.0. Okay. And the name is bin Hadoop. This is the location where it is stored. This is the name of file, right? Now, when I run this, you see, yeah. And when I import here, now the import, what is it? Import PySpark. We will able to run. What's in it? Is of let me just quickly once again check the security groups, because sometimes the security groups is also a problem. So we can have a look of the security group. And since I can see there is a problem that I believe so is a problem of some packages of pip also, because that exact argument is not able to be readable. So one problem should be this. Let me just quickly check if it's possible here to know. Even applied already is security group. Yeah, so this is a step, I believe we can solve this. That's not a big challenge. We need to check like exactly sometimes some IP is blocking, something has been blocked here. So we need to create this network VPN, so secure VP and all, and then that's how we will able to resolve. But again, for that, need to discuss few services. I need to check. So that way we can resolve it. The idea is just to make you understand, like how, if you wanted to access Spark using on EC2, okay, if you have a Spark over there and you wanted to install, if you have a EC2 and you wanted to install a Spark distribution over there, you can actually use it. So, we have downloaded certain necessary packages and accordingly we will able to do that. So this is the one way we can actually use the Spark. There are a number of other ways, like the same is a Jupyter notebook that you have installed here now. By doing every single step in, if you are using EMR, you just have to, create the cluster of EMR, and there is an option of Jupyter notebook that you can directly access the Jupyter notebook from there. So, those are PaaS related services, so it make it easier for us. Because when you are creating your own infrastructure, you need to take care of multiple things. You need to take care of different APIs, packages, multiple things you need to look into that, right? So, and network, if network, like we are getting a problem of network, so it could be due to multiple reasons, right? It could be based on, the local network, it could be based on our browser, it could be based on our the security allowance and all, like you can see that. So multiple thing is there that is dependent. So for that, there is other services that allow us to, resolve the issues and do in a better environment. But this is not the idea. We have an idea that we will be using, some other PaaS services like Databricks and all, and on AWS, and we'll be trying to apply and use it. This is an option that if in future, if you were to reduce your cost to do transformation over the big amount of data, so you can access, like on this here I can mount the S3, here I can mount the S3 and write the IAM access, and I can write the code, and I can do whatever I wanted to. I can do on Jupyter, on Databricks, I can do from here as well as, right? And I can use other services and I can deploy that. So that is how, we can actually utilize it. But yeah, Databricks allow us to give the monitoring purpose as well as, so that the another monitoring services we can use, and we can use for the create our own another pipeline. So this is why I have discussed with you. Now, yeah, this is what just a quick understanding about it. You have to ask anything, you just, if you are working on it, I can try to help you to open it up, or you can ask me a question related to that.
Yeah,
Hi, Deep. Actually, in that, after you did pip install PySpark, right? Inside the node section, we can see by passing break system packages in the second line, last command, we can override the OS like already installed packages. We can
Means?
override already installed. And if we add that argument, and it will
No, what you said again?
that in the node section, error and second line end.
In second line here.
No,
Here.
node section. Node section.
Note, acha. If you believe this is a mistake, please contact your Python installation or OS distributor. You can override this at risk of breaking your Python installation or OS by passing break system package.
If you pass, then it will work.
Okay, you are saying this. I need to mention here this, right?
No, in above command in fourth line after pip install PySpark, add after that add an additional argument, that is
break system package, right?
Double minus, it is an argument.
Okay.
With space, space
After PySpark space?
Yes, space, and you can paste that. 2 minus break.
2 minus. Okay, is that right?
Yeah. You can execute it.
Oh, it's still setting it up. Oh, it's still showing an error. Why?
Dipesh, I think you need to restart your kernel. After that, it's working for me.
Okay, this one. Kernel.
Yeah, you need to restart.
Oh, great. Means we can, like We can do a lot of basic um, reading of data and all. From voice, talk, still, yeah, it's working, and you can see that Spark session dot builder app. Spark session builder dot name. Yeah. Yeah, I mean, you can see that we're able to do a, you know, yeah, I mean, we are, um, yeah, here it is. You can see that.
I think native libraries like WinUtils is not available, but still we can use that Spark session.
Correct, 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 correct. So you all are able to access it?
No, Nikhil, not able to access the
Oh, same issue.
No.
Uh-huh.
my case actually the server is there, but still I am not able to hit the server.
Can you share your screen, even though I can try to help you?
Is my screen visible?
Yeah, yeah.
Yeah.
Can you
So
check your settings of what we say, Spark?
so here actually I'm like what I did is this is my public IP, right?
Mm-hmm.
Just public IP, then the subnet not able to, like, it is saying can't reach this page. This is only I'm getting, not able to access itself, the Jupyter notebook. And then I went here in security groups. Here also I changed the inbound rules, right?
Okay.
So this is IPv4 now. Custom, it is saying custom only because like
Mhm.
you see I do change here, it will say you have not made any changes basically. So I guess this is the same for this
Correct.
you have not made any changes. So I will just go back. But like this is basically the security group created, but still I am not able to. This is the server also which is running state, right? What I did is just took this and then took this and basically replace this local host with this IP, public IP. But still saying the same error. Like it's not able to at all. Like, I'm not getting any logs as well. So see, it will just run here, but I'm not getting anything here. It's not hitting the server somehow. I tried to restart the server 2-3 times, but still it's the same. Not able to open the Jupyter notebook itself. Other steps I have done already.
Okay. Can you restart the system?
EC2?
Yeah, easy to restart and then try, so okay. So meanwhile, can you stop sharing? Let me so this is what like the way easy to we can create. You can create later on, you try. I have told you the steps. I have told how you can access this and how we have opened up this one. And we have used this. Similarly, if you wanted to access the web UI of a Spark, I believe it is I think 4040 is the command. Yeah, this is the Spark web UI. Yeah. So all the DAGs, the stages, the storage environment, executors. We have not executed anything, but this is what the complete properties of Spark. We'll be discussing this little in detail in our coming session. But what I'm trying to tell you, once we install this as Spark and all, then you can actually, if you run any one of the data here, if you go through and if you execute here any program, okay, then you can see into this Spark that what are the jobs you have submitted, what are the stages has been created, how much storage it has uses, okay, environment, executor, everything you could have see this. This is the executor page. Right now, there is no execution happen. So you can see this. Yeah. Do you have any question, guys?
I think we are still catching up to get that worked. So, Deepesh, this is something on which we are going to have the rest of the sessions dependent, or
No. This is something. Yeah, see, what I have told you is that this is a Spark from scratch we have installed. Means, of course, we will be doing this only. We will be writing code like on Jupyter Notebook we are doing here, right? Something. Similarly, we will be writing on Databricks, right?
Okay.
That user interface is also same. Everything is same, right? The only difference is that is a third-party platform, Databricks, right?
Yeah.
But we will be doing the same thing. Like I'm writing the code here now, you will be doing the same thing. And we will be going to do execution. We'll be writing. We will be seeing these things only similar. This I've told you from the scratch. Scratch means if you want to create your own notebook, if you want to create on any infrastructure, either in your window machine, either in your, like any other machine in-house. So how can you do this? This is the process I have discussed with you. And how can you use AWS services also and something like this?
This is without Databricks.
Without Databricks also.
This is without Databricks, right? That's what it is.
Without,
Directly
this is without
creating
Databricks, yeah.
creating infrastructure and then using
Correct.
the Spark and other.
Correct,
Okay.
correct. So the idea is to use the Spark only, right? Why we use Databricks?
Correct.
To use the Spark. Okay. And
Mhm.
Databricks is something that is allow you to, like to create the complete life cycle. That is also having a notebook. You can create this, but apart from notebook, there is a storage system, there is a delta table, there is a computing the resource, you can scale up, they have their own benefits.
Mm.
So
That's the framework. Okay.
it's a framework. And so on, Snowflake. But Snowflake and Databricks both have their own architecture. But we'll be working into these kind of environment only. Like in this Spark, we are writing this on Databricks. You will be able to write in their cell Scala, Jupyter, PySpark, and Python. Any program inside the cell only. So they have some similarity in Snowflake also. You can write SQL, Python, and any other programming language in their notebook. So that is what the good thing with that. Okay, so you guys can try this up once again. Even after this, you will just try to restart, or maybe try to delete the machine, and you have steps given to you guys, right? So you can create your new machine, because what happened, because we are creating infrastructure as a services, and you may be creating in your own personal machine or maybe company machine network. These things you can try opening on another browser. So troubleshooting you need to do, because we are accessing on other accessing from any IP, additional IP. So maybe it can block, so maybe that could be a reason. Otherwise we need to look one by one everyone's, and that is how we can try to resolve. But you have a step. I have given all the process and steps that is mentioned over there. Try to open accordingly and do this. And use, instead of opening, try this just to open Jupyter Notebook. Please, can you try this step I am just sharing with you? To open Notebook, instead of writing Jupyter Notebook, you need to write this loopback IP. Jupyter Notebook IP, no browser. Don't use that. Can you try now? Are you using only Jupyter Notebook directly? Just use this one. Can you use this one, Maitre, or anyone, and try this to access now?
Only I used actually.
Huh?
But still it is not hitting.
You're using this only?
Yeah.
You execute this command when you are installing Jupyter, right?
No, this is something to open the link, open the Jupyter Notebook. Okay, you guys can try this back to your, when you have a, when you think so, you can do that. And come back to me tomorrow. We can discuss if you have any problem. Try to look into that. Apart from that, if you have any question, you can ask me. Okay, good enough then. Then please have a look and try this once again, and let's connect tomorrow. Don't have any question?